Today we introduce a class of problems where we're given the sum and the product of two numbers. We try to find the sum of powers. In this case, x to the fifth plus y to the fifth. This represents a class of problems. Sometimes we are given the same thing, but we need to calculate the cube, x third plus y to the third, right? So here, notice that this polynomial here is symmetrical in x and y. That is, you swap x and y, the expression remains unchanged. So this represents a class of problems, and there are two different methods. It is good to know both. Let's get started. The initial analysis is that in order to calculate this expression, you have to know x to the fifth plus y to the fifth. All right. In the first method, we're dealing with sum of powers. K, when k equal to 1, that's x plus y, that's given, right? So what about k equal to 2, 3, 4, and 5? Sometimes we need to solve this. In our case, we have to solve x to the fifth. Now, usually x to the fifth can calculate from maybe to the third and second, or to the fourth and to the first, right? So in general, in the method 1, the way we do it is we based on some initial sk, and we move from sk to xk plus 1. For example, once we know s1, s2, simply multiply this by x plus y. So here is s2 is equal s1 squared, right? s1 times s1 minus 2xy, because there's some cross term, that's 20. Now how about s3? Again, multiply s2 by x plus y. So x3 here, you multiply this, you introduce some cross terms, you subtract the cross terms here, and again this could be xy times x1 s1, which is x plus y, right? So that's 88. How about now for S3, there's some other method. Is sometimes you can S3 can be calculated from this formula here, x plus y to the third power minus this extra term here, yeah. So which will give you the same results. All right. So here, this is also 88. Okay. So let's look at S4 now. So S4 is equal S3 multiplied by x plus y minus the cross term here is xy times S2. So that is 392. Now x5, you use the same pattern here, would be S4 times x plus y, which is S1. So this is S4 times S1 minus this is the product, and then this is going to be S3. Okay, plug in the numbers. Notice that I don't calculate here because there's no need to do so, because later you're going to cancel number 4. Okay, that's another trick you probably want to use in the actual exam to save you time. Sometimes don't try to calculate big numbers. All right, so we have this is what we have so far, and the expression we want to evaluate, we can just plug in, right? So when you plug in here, notice that this 4 cancels, okay, and this is 440. So the answer is D. Now this is method number 1. We calculate from S1 to S2, S3, S4, S5. Okay, so now the second method, which personally I prefer the second method, it is that the fact that if you know the sum and the product of two numbers, you know that both numbers are the two roots of a quadratic equation. Yeah? So we claim that x, y are roots of this equation. In other words, x satisfies this equation, y satisfies this equation, and then from here we know that t squared equals 4t plus 2. Notice that any square can be replaced with a linear term. How about t to the third power? We claim that any power greater than 2 can be expressed in linear terms. okay, including x to the fifth. Now here's the trick. T to the fifth power, right, is equal t times t to the fourth power, or square, right? If you square, of course t squared is the linear term. We replace with the linear term. And then when you express it out, you're going to have this term here. Again, t squared can be replaced. Anytime you have t squared or higher, you can replace with the linear term. Okay, so what you get is 16 times 40 plus 2, the linear term. You combine the whole thing, this becomes t times 80t plus 36. And then you multiply t, right? You're going to have t squared again. Again, you're going to replace with 40 plus 2. Okay, 40 plus 2 here is replaced. So what we get is t to the fifth power, yeah, replaced with linear term always. Okay, so recap. X and y are the roots for this equation, so we claim that any higher power can be replaced with a linear term. We went through the process. T to the fifth power can be replaced with this linear term here with coefficient here. Now we try to calculate x fifths plus y to the fifth. Because both x, y satisfy this equation here, you plug in, you plug in x and y, you add them together, you become this one times x plus y, and 160 appears twice, so it's going to be 330. That's good. That's S5. Okay, don't calculate it because we're going to cancel that later on. So here, the original expression, you plug in the numbers, you get the same results. Notice that here, the method number 2, which I personally prefer, we use the equation to reduce the power here, higher power, to the third, to the fourth, to the fifth, or to the sixth. You can always reduce it step by step, and then eventually you become a linear term. Once you have a linear term, you do the math is easier. Okay, so hopefully you follow the both methods here, and you're gonna be able to solve similar problems in AMC or other contests. Thank you. Please, share and subscribe to the channel.